All right. So this graph is looking at limits. I can ask you any limits I want off this graph. Okay. So there's a variety of ways that you can see the limits. So you have the limit as x goes to infinity, like the first one. So this is looking at basically a horizontal asymptote. What's happening as this graph is going to infinity. It's going to -2. Okay. So we're just looking at that as it goes all the way out to infinity. So in essence, that's a horizontal asymptote. Which is what the last question's asking. Remember, the limits as they go to infinity, you can only come at them from one direction because you're going out to infinity. That's that horizontal asymptote. Any other point inside the graph, you can't. You have to look at it coming from both directions. The other next one was the limit as x is going to negative infinity, and this one's going to +2, which is also horizontal asymptote. Next two questions are asking you from to one specific spot. So I have the limit as x goes to 1. Now, these places, you have to look at them as it's coming from the left and coming from the right. So this is the same thing as saying the limit as x goes to infinity from 1 positive and 1 negative. And they both have to equal the exact same thing. So in this case, as we're going to 1, it's going to positive or infinity. And this side's also going to infinity. So my limit as x goes to 1 goes to infinity. And that actually is a yeah, because it goes up to that point. And x goes to 3 is actually going to negative infinity, and it's the same thing. That is also a vertical asymptote. So I have two horizontal asymptotes. I have y equals -2 and y equals +2. And two vertical asymptotes, x equals 1 and x equals 3. Those are my asymptotes. I could also ask, what's the limit as x goes to 4? So that would be that point right there. So in that case, my limit's going to 1. I could have a hole there and a point here. The limit would still go to 1 in that situation as we're going to 4. Let's erase this point right here for a second. In this case, if I was still going to 4, the limit from the left and the right side goes to two different points. So in this case, my limit would not exist. Okay. So all these are possible ways that I could ask these questions. Okay. Any questions on the limits? For this one, you'll be given a graph and you're coming up with probably 4 or 5 different limits. I may or may not ask for the asymptotes. I haven't decided yet on that one. All right. Let's look at the next one. This question correctly. All right, the next 5 questions are all derivatives. So you're asked to find the derivative of each of these functions. All right, so take a few minutes, find the derivative. All right, which derivative rules are we using for this one? So this one is just the power rule. What is the power rule?
Bring down the n and then reduce the n by 1.
Okay, so bring down the exponent. Yes. So n x to the n minus 1. All right, so b prime of x in this case, we have 5/8 times 2, and then x to the 2 minus 1, minus 8 times 1, and then x to the 1 minus. I know I'm literally writing all this out, and I do not have to. The 17 goes to what? 0. Your constants disappear. So this becomes 5/4 x minus 8, because 1 minus 1 is 0. The one derivative rule that most people all get right. And the one thing that you'll totally screw up when you start doing the integration, because it goes the opposite direction, and you're like, wait, which direction am I going now? Yeah. All right. So I should put the integral test right after the derivative one, right? So you can see if you can screw them up. Then we do derivatives. Nah, there'll be a few on there. All right. Find me this one. Yes. Times e to the x. rule am I using for this one?
Product.
Yeah, the main focus is the product rule. What's the product rule state?
Prime times G plus F.
So derivative of the first times the second plus the derivative of the second times the first. So for this one, we need to identify each of the two pieces and then find the derivative of each part. So if we make f equal to the x plus 7 third of x, we can rewrite this one to make it a little simpler. This way now we can use the power rule on it. So f prime in this case would be what? Yes, don't forget the 1. So it's 7 over 2 square root of. Remember that this is one of those ones that comes up quite often. Just remember that's just 1 over the 2 squared of x when you take the derivative of it. So that comes up quite often. We have g is e to the x. So g prime is e to the x. So f prime of x, we have the first, so 1 plus 7 over 2 squared of x times the second, plus x plus 7 squared of x times the derivative of e to the x, which is just e to the x. You can leave it like that, or you can pull out the e to the x, because there really isn't anything you can do to combine any of the other stuff in this one. So I can't put anything in there together to make life easier. So any questions on the product rule? All right. All right, work on this one. rule am I using on this one? Quotient rule. So remember, it's very similar to the product rule, except it's a minus. And then it's over P squared. All right, so the other way you can actually look at this one, if you want, instead of doing the F and the G, is numerator and denominator and D. So either way. So my F is the cubed root of X, which is X to the 1/3. So F prime is what? And then it'd be X to the negative 2/3, right? So if we clean this up, it'd be 3 cubed root of X squared. You can leave it as a fraction. So we'll see when we plug everything back in if the fraction or the root's easier to deal with. G is the X minus 3. So which G prime? It's just 1. All right, so I have we have 1/3. I'm going to leave it as the exponent for a second. Times X minus 3 minus X to the 1/3 times 1 all over X minus 3 squared. Does that part make sense? All right, let's see. If I take out an X to the 1/3, let's clean this up. This will actually, we'll clean it up a little bit. This becomes 1/3 X to the negative 3 over 3, which is just 1. Makes my life nice. Times X minus 3 minus 1. So we have the cube root of X. We distribute that, we get 1/3, because X times that's going to be that, gone. 1/3 times negative 3 is negative 1. So it's negative 1 over X minus 1 all over X minus 3 squared. That's nice. We can leave it like that. So if you don't go from here to here, I'm probably just going to take off a point or so just for simple, like, because to really simplify it. But there's a few different ways you could get down to there and simplify it. It doesn't necessarily have to look exactly like that. So hold on. That's just the top. So if you pull out this piece right here, you're in essence subtracting that by both ends. So that's how you get the -3/3, which is the -1. If that's what you're asking. If not, tell me and I can explain where I got it.
So they did the x to the two-thirds, like minus the x to the like
Yeah.
if I understand that x to the -1, I just don't know why the x to the 1/3 is the one, but then also x to the 1.
Okay, because I'm basically factoring out x to the 1/3. So I'm pulling out an x to the 1/3 here and from here. That's how that one becomes by itself now because I pulled out that x to the 1/3. It's as crazy as it sounds, it's literally the same thing as if I said if it was x squared, x minus 3 minus x squared. That's the same thing as saying x squared, x minus 3 minus 1. Right? Because I'm pulling out the x squared. Same concept. That's why there's still that 1 there because I'm not, this term's not disappearing. So that I didn't just move that to the front, I factored that out. And it's more confusing because it's a third, which is normally not something you would typically factor out. Okay. All right. I can use any of the trig rules, the trig derivatives on the test. Okay. So it could be any of those six that are going to show up. So if you don't remember them, might want to be on that sheet of paper. There is a reason I give you a sheet of paper.
And all the,
So if you need rules, I write them down. Well, the nice thing is, those are your integral rules too.
they're more important.
Right, but those, you wouldn't have to write, what I'm saying is, you don't have to write this down twice. So remember, those are the six derivative rules. Going backwards are your six integral rules. So by writing down those six, you in essence also have the six integral rules for those as well. Okay? So save space. Don't write things twice if you don't have to. Remember, the derivatives and integrals are just inverses of each other. So we have, in essence, those same things there. All right, so I need to obviously use the rule for tangent, and I also need to use the what? The quotient rule for this one. Now, this does not mean that the quotient test on your final will, or the trig rule will be in a quotient. I could have made this a product rule or anything. All right, this one's just one that's going to have a trig problem in it. You will have at least one with a trig problem. So same concept that we did with the last one with the quotient rule. Let's find each piece. So the top is 2x. So the derivative of that is just 2. G is 9 minus tangent x. So the derivative of this is secant squared x.
So would it be negative secant squared x? Or positive?
Oh, it would be negative, you're right, because there's a minus sign in front. I was like, wait, no, the rule's not there. Yes, that sign. All right, so we've got 2 times 9 minus tangent x minus 2x times negative secant squared x over 9 minus tangent x squared. So we've got 18 minus 2 tangent x plus 2x secant squared x over 9 minus tangent x squared. You can pull out the 2 if you want. It doesn't make much difference. The big thing in this one is I don't want to see the 2 negative signs. And you do not have to FOIL out the bottom. Anybody still need the trig rules up there? Yes, both sides. Technically, what I used to do is you used to have your four index. I had four tests, so you had four index cards, and if you think about four index cards, make a sheet of paper. So people used to ask, "Can I bring my index?" Yeah, you can bring your index cards or a sheet of paper. If you already had it all in your index cards, just bring your four index cards. You're fine. So that's where the piece of paper came from. All right, what do I got to do on this one?
That's the first chain rule.
Yes, so I have to do the chain rule on this one. So this one would be the chain rule. Well, we have to do the chain. What are you doing first? No, I'm actually asking, what are you doing first? Okay, but that is in essence, the reason you have to do that is because you have to find the derivative by the chain rule. So you still are doing the chain rule first. The chain rule tells you have to find the derivative of that first, which is the quotient rule. So you're doing the chain rule, but the first thing you have to do the chain rule is the quotient rule of the inside. So yes, you're correct. She's like, I don't get what you're saying. It's fine. All right, so I've got f with the g inside. So it's the derivative of g times the derivative of f, basically. All right, so in this case, my g is x to the third minus 2 over x to the third plus 2. So I have to do the quotient rule for this one. All right, so my numerator is x to the third minus 2. So n prime is 3x squared. My denominator is x to the third plus 2. So my denominator is 3x squared. So the top becomes 3x squared times x to the third plus 2 minus 3x squared times x to the third minus 2. So we've got 3x to the fifth plus 6x squared minus 3x to the fifth plus 6x squared, which comes out to be 12x squared.
That over.
Oh yeah, I haven't done the bottom part yet. All right, that was just literally the top. So my g prime is 12x squared over x to the third plus 2 squared. I don't think so in this case. It's not going to really break anything down anymore. All right, so now the chain rule. So I have my n prime of x. So it's that piece first. And then if I remember right, it was 8, right? Yeah. So it's going to be 8 times x to the third minus 2 over x to the third plus 2 to the 7th power. And I guess technically you could do this. You could split the 7 on the top and the bottom. If you left it as the one, if you left it as this one here, if you left it as that, it'd have been fine. I don't want to see this. That I want to see simplified. But if you didn't go down to the last one, that's fine. I literally looked at it like, oh yeah, I could kind of put that together, but that's not something that I would have expected everybody to do. Like it's fine as it is. If you're going to have to find the next derivative, like this, the second derivative and stuff like that, you probably would have wanted to go down to that other piece just because it would have made it a little bit simpler for you to do. Yes. Hold on. I will get you the official formula for the chain rule because I know the one I wrote wasn't really that great.
Everyone be written down, but it's different from when you.
I know. That's why I said I'm going to get you the chain rule, the actual written chain rule. Where is it? There it is. Here is the actual chain. The only thing I didn't put was technically that's still g of x and the g inside of the f prime of x. So we had, this was the f prime of g of x, is that x to the third minus 2 plus that to the 7th times 8. No, this. So this was that f prime of g of x, and that was the g prime of x. I just wrote it opposite direction. but you
So
could,
the 12x.
that's your g prime of x. Yes.
Okay.
And then this is the derivative if the middle was just a single x, basically. You typically, the chain rule ends up coming into play a lot when you have like powers like that. So. All right. Questions on just straight derivatives?
Wait,
Yes. F prime is the 8 x to the third minus 2 plus to the 7th. That's the F prime.
so that's prime and then the.
Yeah, that's that. That's that. And then this is that. So for your straight derivatives, you need to make sure you remember the power rule, product quotient rule, chain rule. You should have your derivatives for your 6 trig functions down. I also would make sure you have the derivative of the e to the x and the ln of x. So I'll throw those up there so you have those, because those are definitely something you should have. We're gonna do that in a second. Have one page with those. Yes, hold up. So these are the other derivative rules you should have that could show up. Yeah, we're gonna do implicit in a second. Where is the one? And for some reason I can't find it, so I'll just write it. Oh, wait, no, sorry, not over. Not over. That's the integral.
That piece representing any base.
Any base, yes.
Yes.
So if it was like 2 to the x, 3 to the x, it'd be ln of 2, ln of 3. If it was e to the x, it's ln of e, which is 1. So that's why it's not there. All right. All right, let's do the implicit. All right. Your implicit differentiation. Try this one. Find the derivative of each piece. I would highly suggest doing them individually. What's the derivative of x squared? What's the derivative of 6xy? For the y prime? Almost. This is a product. You need to use the product rule for this one. So what's the derivative of 6x? 6 times y plus 6x times y prime. So 6y plus 6xy prime. I don't know how you got 32. Oh, well, you would have got 36, not 32. That's what I was like. If you had said 36, I totally would like, okay, I know exactly. I'm like, 2. All right, 12y squared. Yes. 28. 0. All right, so now we have to put all this back together and solve for y prime. So I've got 2x plus 6y plus 6xy prime plus, they were all pluses, right?
Yep.
24y y prime equals 0. So what's the next step we're going to do for this one? Right. How are we going to solve for y prime? Yeah, get the y primes on one side, like the terms of those, and the other things on the other side. So we'll leave the y primes over here. And we're going to move the other stuff over. So negative 2x minus 6y. Now that the y primes are by themselves, I can factor that y prime out. And then I can divide. All right. Does that answer the question?
No.
Yeah. One of the problems will ask you to find me the equation of the tangent line. It doesn't have to be this one. I'm probably going to make it this one, the implicit differentiation one. But I guess technically it could have been any of the derivative ones I could have had you do this to. So, all right. So we've got our point. It's at 2, 1. So we've got our derivative. And my point is 2, 1. So to find my equation for a line, I need the point and I need what? So what's M? The slope. I need my slope. What's the derivative give you? Your slope. So we're going to plug those numbers into my derivative here, and we will find my slope. So negative 4, negative 10 over 36. So negative 5 over 18. So that's my M. So then we y minus y1 equals m times x minus x1. So y minus 1 equals negative 5 over 18 x minus 2.
What was that bottom part?
This?
Yeah.
That's your equation.
Oh, so like.
Now, if you want to do it as the y equals mx plus b, 1 equals -5/18 times 2 plus b. So 1 equals -5/9. So we've got add 5 to 14 ninths. So y equals -5/18 plus 14 ninths. They're both exactly right. I used the point slope equation. Y equals mx plus the slope intercept equation. They're both correct. They're both two equations of a line. Point slope. I just didn't have to do my fraction. I think most teachers like the slope intercept form just because it's neater. But the point slope is just as easy or just as good. All right, two more problems today. And then I'll do the other 5 problems or 6 problems on Monday. All right, find me my limit. I haven't done it yet. Yeah.
No, I'm.
All right, what do I got to do for this one? Why? Okay. Key pieces here. Always do that. Okay, remember. Always plug in the number first. It did actually. On the last test, I had one. I'm like, I had one. It's to say that you did not have to do the Hoppy-Tolles rule. So always make sure you check that first. That's the easiest thing to do. It's like it doesn't take a lot of work to do. So try it. If you plug in 1 to this one, you have sine of 0 over 1 to the third plus 2 to the times 1 minus 3 comes out to be 0 over 0. So I have to use L'Hopital's rule for this one. So L'Hopital's rule states what? Okay, so if both are differentiable, not indifferentiable, are differentiable, we take the derivative of the top and the bottom, and my limit still is there. Yeah. All right, so I take the derivative of sine of x minus 1. What's that? Why? Yeah.
Chain rule.
Yes, make sure, in this case, you still have to use the chain rule. The derivative of x minus 1 is 1, so you didn't have to put anything out in front. However, if it was x squared minus 1, it wouldn't have been. Okay, so keep that in mind when you're doing that. You might have to do the chain rule and it might actually matter. And if it was x squared minus 1, this still would have been 0 over 0. So bottom is 3x squared plus 2. Okay? So now I'm going to do the limit as x goes to 1 of this. So if I plug in 1, I get cosine of 0 over 5. Cosine of 0 goes to 1, so this goes to 1/5. Okay. If for some reason it didn't work here and we had to do it again, you could do L'Hopital's rule again. Okay. So just because L'Hopital's rule, if it gives you 0 over 0 still is something that's undefined, you can keep doing L'Hopital's rule. So. All right. Now, I will tell you on the actual test, I will not ask every one of these questions.
15 questions turned into 45.
Okay. So, there's actually only 14 questions listed on the test, on the practice test. I'm going to make another one up. It'll just be one similar to one we have there. This one will ask you a few of these questions. It will not ask you all of them, but I figured I'd put them all in there so you actually have the notes for them all. So we've got that function. We need to find the domain, x-intercepts, y-intercepts, where it's increasing, where it's decreasing. So for your domain, that one's pretty simple. X-intercepts, you're plugging in 0 for y. The y-intercept, your x is 0. Increasing and decreasing, first derivative. Concave up, concave down, second derivative. And your local min and max is your first derivative. All right. I'll give you what? 15 minutes, you think you can get them all? Or at least get close? All right. So I'll give you 15 minutes and then we'll go through them. Yeah.
And then decreasing my plug numbers here into the derivative.
Yeah.
I think so.
Yeah.
Is the person to the derivative second becomes negative forms possible. It's always not easy.
It is possible in all case contact now. That is a possibility. All right, 5 more minutes and I'll go room. All right, let's go through them. All right, first one. Domain. What are my possible domain restrictions?
All real numbers except 0.
Okay. For this one, yes. What are my domain restrictions in general? Because it might not be just an x squared, or it might not be a division one at all. So my denominator can't be 0. And your logs have to be greater than 0. Or actually, even if it's greater than or equal to 0, actually. All right. Because it technically could be any of those. I don't necessarily have to have a division problem there. So for this one, it's a division by 0. So I said x squared has to be cannot equal 0, which in this case is simple. X cannot equal 0. So my domain is negative infinity to 0, and then 0 to infinity. All right. So that's my domain. Next question was x-intercepts and y-intercepts. Well, if the problem can't equal 0, when x is 0, x equals 0 is your what? Your y-axis, right? So is there a y-intercept in this problem? No. Okay. So, and we can show that easily. Remember, y-intercept is plugging in 0 for that. So you get 0 minus 4 over 0, which is negative 4 over 0, which does not exist. So there's no y-intercept. Yes.
I just forgot about the does not exist, never like applied to.
That's fine. Yeah, that's fine. All right. So your x-intercepts, that's where y is 0. So I have 0 equals x minus 4 over x squared. So I have 0 equals x minus 4. So x equals 4 is my x-intercept. Oh, I know the actual questions I forgot to ask on this question. We'll do those too. All right. Any questions with the x and y intercepts? All right. The question I forgot to ask on this one. is horizontal asymptotes. I asked in the beginning one, but so my looking at it as it goes to infinity. So x minus 4 over x squared. If I plug in infinity to that, I'm going to get infinity over infinity, correct? Okay, so that means I need to do L'Hopital's rule. So the derivative of the top is what? 1. Derivative of the bottom is 2x. And that then goes to 0. So as x goes to infinity, the function goes to 0. If I plugged in negative infinity, I get negative infinity over infinity, which is still infinity over infinity. So I do have to do the L'Hopital's rule again on this one. So this one also goes to 0. So my horizontal asymptote, so my end behavior, basically, these both go to 0. All right. Next asked, where is it increasing, where is it decreasing? So what do I got to find here? Find my first derivative, right? All right, so the derivative of the top is 1. So I have 1 times x squared minus 2x times x minus 4 over x to the 4th. So we have x squared minus 2x squared plus 8x, which is negative x squared plus 8x. So I got x, 8 minus x over x to the 4th. So 8 minus x over x to the 3rd. This is one of those ones that, since we're going to have to find our second derivative, you kind of want to simplify it down as much as possible. All right, so now we need to know where this is increasing and where is it decreasing. So to do that, I need to do what? I need to find my critical number. So that means where it equals 0 or where it does not exist. Okay, remember your critical numbers are both. The 0 one is what everybody focuses on, but in some situations we have where it doesn't exist. This one I do as well. All right, so we have 0 equals 8 minus x over x to the 3rd. So I have 0 equals 8 minus x. So we have x equals 8. And then we have, if x is 0, it does not exist. Okay, so my critical numbers are 0 and 8. So now we just look at our number line and we plug numbers in. So let's use -1, 2, and 10. and you're plugging it into your first derivative. So if I plug -1 into this, I get a positive on the top over a negative on the bottom. So it's a negative total. If I plug 2 in, I get a positive on the top and a positive on the bottom. So it's positive. If I plug 10 in, I get a negative on the top and a positive on the bottom. So it's negative. Remember, I don't really care what the numbers are. I literally just care about sign. So it is decreasing from -infinity to 0 and from 8 to infinity. And it is increasing from 0 to 8. What else does this tell me? Yeah, it'll also help me find my local min and max. So in this case, -1, it's going down to 0 and up from 0. So that would be a min. But we also know that point doesn't exist. So, so there is no minimum in this problem. The max is where it increases and then decreases. So my max is going to occur at x equals 8. So I have no min and a max at x equals 8. So I got to plug in 8 to my original problem. To find my minimum, my maximum. So y is 8 minus 4 is 4 over 64. So I have 1/16. So my max is at 8 and 1/16. That's my max. And there's no minimum in this problem. All right. The last thing we had to find is concavity, concave up and concave down. So for this one, I need to take my second derivative. So let's get my first derivative. So I have -1 times x to the third minus 3x squared times 8 minus x over x to the sixth. So I have -x to the third minus 24x squared plus 3x to the third. So 2x to the third minus 24x squared. I can pull out mx squared. So I have 2x minus 24. So my second derivative is 2x minus 24 over x to the fourth. All right. Any questions with that? All right. So now how do I find my concavity? Find my what? Critical numbers again. So again, same thing, where it equals 0 and where it's undefined. So in this case, 0 is 2x minus 24 over x squared. So 2x minus 24 equals 0. So x equals 12. And it does not exist at x equals 0. So I have two critical numbers again. So again, plug my numbers in. So -1 is going to give me a negative on the top and a positive on the bottom. So that's a negative. 5 is going to give me a negative on the top and a positive on the bottom, which is a negative. And 20 is going to give me a positive on the top and a positive on the bottom, which is a positive. No, second derivative. Just like the derivative, we're looking at where that derivative is positive and negative. The only time you're going to plug back into the original problem is to find a point. So if I asked you what was the point of concavity or the point of inflection, then we would take the 12, we'd plug it back into my original problem. So notice this one does not always switch. Okay, so in my first derivative, it switched back and forth. Second derivative doesn't. It does not always have to do that. Okay, so don't make that assumption. It's a very easy assumption to make. Oh, it's just going to switch from negative, positive, negative, and not having to do the math. Do the math. So in this case, I have concave down from -infinity to 0, and from 0 to 12, and up from 12 to infinity. Yes. I was literally going to say that. It will be wrong if you do -infinity to 12, because it doesn't exist at 0. So you have to eliminate that point. See how I anticipated your question immediately? Yeah. All right. So if you remember, this one is one of those ones you're looking at a graph, right? So you can use the graph. Concave down, it's all there. Like, it makes sense. And then at some point over here, it actually switches. At 12. Okay. All right. That's part 1 of your final. Monday we'll go over the